Okay, hello, good morning to all the students. Okay, for the student, you on the line, now you are watching. Can you reply me? That means you can listen me or not. Okay, for my student, got time watching here. Okay, can you listen me? Okay, morning, Yiru. Can listen me or not? Okay, anybody can feedback? Okay, can Esther? Okay, so I will start my lesson. Okay, today I will go through to 3.3. I think you also got the access, the module, the notes. So from here we go through the EMF. Okay, another one should be the internal resistance. Okay, actually we learned before we got current. Then after that we got the we learn about current and also potential. After that, we got resistance. Okay, now we need to introduce another thing. That's a EMF. EMF actually the same like the unit for the potential difference. Okay, internal resistance also same unit with the resistance, but this one is detail is related with the battery. Okay, we're talking about the battery things. Okay, let's see here. We go through what's related with the battery. Okay, so the first one, EMF, actually the name we call it electromotive force. Okay, electromotive force. Okay, then we go through. Okay, let's see the diagram. Diagram, they show a simple torchlight and its circuit consistent of the cell, battery, or you say the switch and also the light bulb. Okay, torchlight. So from here, when the switch just close, okay, then the circuit is complete. Is it close mean on? When you just on, the circuit become complete, then the bulb will be light up. Then showing the current flow in the circuit. So this flow of the current is the flow of the charge. Okay, what causes the charge to flow? So from here, you think about the current. Okay, current come from where? Come from the charge. Okay, how come the charge can move? Who helped the charge to flow? So this one we need to discuss. That means we're talking about what will start from the battery to let the charge go to move. Okay, so that means you got sure some of the thing to let the charge move out. Okay, when the charge just move out, that means you got current to flow through the circuit. So what you need to learn today is the thing to let the charge to move. Okay, from the battery. Okay, let's see what is that. Okay, so you can see the diagram. Okay, we got separate by open circuit and closed circuit. So from here, this one is a EMF. Okay, let's see the EMF, electromotive force, the symbol. The symbol just like the E, okay, but they got some italic, okay, just like the E. If you write the capital E, there's a okay. Okay, the same like the EMF. Okay, let's see what's the EMF. Okay, the diagram. Battery is a source of the electrical energy that move the charge around the circuit. Okay, number two, battery that will convert the chemical energy from where? From the battery. Okay, they store in the electrode to electrical energy. Okay, now the energy they supply move 1 coulomb of the charge in the circuit. Okay, the charge 1 coulomb, they will start to move through the circuit. Okay, now every 1 coulomb of the charge that flow through the battery, they will receive electrical potential energy to move the circuit, to move in the circuit. So that means the charge you want to move, you sure got the potential energy. That means you got electrical energy. There's a one of the energy where they come from the battery. Okay, this one energy that help to move the charge through the circuit, then go to the bulb. Then the bulb can be light up. So just now we got one of the question, why the charge can be moved. Okay, because they got electric potential energy. Okay, electric potential energy, that means they will kick the charge, go to move. Okay, so from here we continue. Therefore, the work is done, no? Because you got energy, is it? So therefore, the work is done by the battery in driving the charge around the complete circuit. Okay, so this was one of the process. Okay, you want the bulb to light up, sure, you must have the current. Okay, before you want to have the current, you must have the charge. The charge come from where? The charge come from the battery. But we don't have any energy to keep the charge. So that means the battery must be supply the energy. What energy? Electrical potential energy. To keep the 1 coulomb of the charge move through the complete circuit. Okay, complete circuit. If I say the before that what we learned for the potential difference, you can see the definition. They just move point to point. So that means you just want to measure the resistor. You put a voltmeter there. So that means you want to measure that resistor. What is the potential difference? But now we're talking about EMF. EMF is a potential difference, but they want to measure what? The whole circuit. Okay, that means this one potential difference, they want go through the whole circuit. So we never call it as a potential difference, we just call it as a EMF. So from here, the definition for the EMF should be what is done by the battery in driving the charge around. Okay, the differences is a complete circuit. Potential difference is point to point, but this one is a complete circuit. Okay, so from here, the battery that provided electrical energy is a source of the electromotive force. Okay, electrical energy come from where? Come from the electromotive force. That means the EMF. Okay, EMF actually is from the battery. Okay, the battery got force, then provide the energy, then keep the charge to move, then got current, then finally the bulb light up. Okay, we got so many processes. Okay, then we go through to the more detail about the electromotive force. Okay, electromotive for example. Okay, from where? From the electric generator. Okay, you can see some generator. We got dynamo. Then after that, we got accumulator. So this one is normally is a battery. That's a sources of the electrical energy. So from here, electromotive force. Then after that, we can say there's an energy transfer, or you say work done, okay, by an electrical source. Okay, important is an electrical source. That means that from the main source, there's an electrical source to move 1 coulomb of the charge in complete circuit. So this one is the differences, EMF and also potential difference. Potential difference, you no need to mention about electrical source. You just say the work done to move 1 coulomb of the charge from point to point. That one is a potential difference. But EMF, you need to mention from the electrical source. Move where? Move complete circuit. That one is called EMF. Okay, so this one is a what differences between the potential difference and also EMF. Okay, although both also is a unit same, unit also volt, but the definition should be the difference. Okay, so we go through the detail about EMF. Okay, this one is a formula for EMF. Okay, energy over charge. So the energy here, we call it that's an electrical energy lah, because the work done, move the charge. So from here, we're using the what? The italic E. Okay, so from here, you're using the normal capital E. So if not, you misunderstanding why got 2 E here, is it? So this one should be the EMF. Then this one is a work done. Okay, or you can put W lah, W over Q. Okay, so that means EMF, the unit should be same like the potential difference. Okay, we go to explain one by one. Okay, this one italic E, that's a EMF, electromotive force. Then the capital E is a energy transfer. We can say work done. Okay, Q is the amount of the charge flowing. Okay, so from here, SI unit for the EMF, we still write volt. Okay, you can write capital letter, volt, or you can say about joule per coulomb. Okay, normally we just write volt lah, capital letter. Okay, then we go through. Okay, you buy the battery, you can find it, they show you how many volt. So this one, we call it as a EMF. That means the battery, they can provide how many volt. You buy the 9 volt, you buy the triple A, double A. After that, they gonna show you how many volt. That one is a EMF. Okay, we go to see explanation for EMF. For this one, 1.5 volt actually what's the meaning? There's a 1.5 joule of energy is needed to move 1 coulomb of the charge around the complete circuit. This one is a meaning for the EMF. Okay, just now you say work done, is it? But the work done now we need to convert become joule lah, because we know there's a 1.5. So we just mentioned 1.5 joule of the energy that needed. Okay, because over Q, is it? Over Q, I mean Q is a charge. So they needed to move 1 coulomb of the charge around the whole complete circuit. Okay, so from here you can see the diagram. Okay, this one is a battery. After that, you straightforward to join the voltmeter, then you can read the, okay, so that means from here inside the battery actually they got the original volt. So this one volt we call it as a EMF, is it? But inside we cannot see. Inside actually they got the arrangement, they become like this. They got one of the switch. After that they got one resistance. Then after that potential difference inside is how many? EMF. That's a 1.5 volt. So this one is a battery. Inside we also got internal resistance. So normally we learn about the external resistance. This one is an external, is it? But inside we also got resistance. That's an internal. Before that we ignore already. We just ignore our battery is no resistance. So we're using the calculation V equal IR, is it? Okay, but this one topic, no. Okay, we need to count again what is the internal resistance, because internal resistance they also will affected the whole circuit current. Okay, so from here, this one topic, they want to learn about something inside the battery. So the voltmeter reading is the EMF of the dry cell. If they just want to measure the dry cell by using voltmeter, so that means that one should be the EMF. Okay, so from here, remember, inside the battery, we need to count about EMF and also internal resistance. So from here, the voltmeter, you can see the small voltmeter, they write VR. This one means they want to measure what is an EMF. Okay, you see the V outside. The V outside, actually, they want to measure resistor potential difference. So different thing. Internal, measure EMF. External, measure potential difference. Okay, so we go through to the detail. Later, you can see the different symbol. We got small r, we got capital R. After that, we got V, then we got VR. So when you see everything is a small r, that one sure is the internal resistance. Okay, so we go through to the next. Okay, 3.6 is one of the activity from your textbook. Okay, they just say to complete the between EMF, compare between the EMF and also potential difference. Okay, we do the comparison. Okay, first one, they're using a dry cell holder and switch. After that, we got bulb. Okay, connecting wire and voltmeter. Okay, the setup as like this. Okay, when starting open circuit. Open circuit means the switch is open. The bulb sure cannot light up. Agree, eh? But you see the voltmeter. Where the voltmeter to put? They never put below the bulb. Okay, because they don't want to find potential difference. So they put exactly above the battery. So parallel with the battery. So that means when you see the graph situation like this, means they want to find EMF. Okay, before that we never see the voltmeter they put above the battery one. Okay, normally it's below the resistor you want to measure. So from here, when you see the graph, okay, when you see the diagram like this, means understood they want to measure EMF. Okay, so arrangement, switch is a switch on. Okay, they're using the holder and battery. After that, they got switch. Okay, they join with the bulb. Okay, then we got the ammeter and also the voltmeter. Okay, so this one is a connection. Okay, you see the voltmeter exactly above the okay, this one is a voltmeter, this one is a battery, exactly above the battery. Okay, they never below the bulb, they just put above the battery. Okay, if the switch is open, actually no current. Agree? No current. But the voltmeter still can read the reading for the battery because you are closed. Battery and voltmeter now is a closed. The rest is open. So that means for this one situation, we can read the reading from the voltmeter. So from here, they show the voltmeter is 3 volt. So this one 3 volt actually is what? This one 3 volt actually we call it as a EMF. Okay. What situation we can measure EMF? When there is a open circuit. Okay, because open circuit, we never touching about the external, is it? We just internal. So that means open circuit, you straightforward to read, that one we call it as a EMF. Okay, so from here we continue. Okay, observe what happened to the bulb and also record the voltmeter reading in the table. Okay, number 3, close the switch. Close the switch means close circuit already. When close the switch, now you observe again what happened for the bulb. The bulb sure will light up lah, and record the voltmeter readings. Okay, so from here I will show you the voltmeter. Okay, this one voltmeter is open circuit. Okay, so open circuit, we find it, ammeter reading 0. Ammeter, not voltmeter. So ammeter 0, sure lor, because no current pass through ma, is it? So closed circuit, closed circuit, that means you got current to pass through. So the current show 0.2 ampere. Okay, 0.2 ampere. If you cannot see, I go to focus. Okay, first one, 0. Nothing to be seen. Okay, so from here is nothing lah. Okay, then we go and see the second one. Second one, when I just close the ammeter, show 0.2. Okay, so when it shows 0.2, then we drop down 0.2 ampere. When open, nothing, no current. Okay, so we go to continue. Voltmeter. Okay, we see the voltmeter. So from here, when open circuit, okay, you see the voltmeter show how many? Okay, we're using the bottom one, the bottom scale. Okay, the bottom scale, they show about 3 volt open circuit. So understood this one, 3 volt actually is what? There's a EMF. That means the battery now is how many volt? 3 volt. Okay, so from here we go to drop down lah. Okay, we go to drop down. This one should be 3. Okay, now we go and see closed circuit. When I just close it, we find it what's happened for the voltmeter. Okay, you can find it drop. The reading drop. Okay, drop to something 2.6 a bit meter, 6 and 8 meter. So we take it 2.7. Okay, 2.7 here. Okay, so from here we just drop down first, 2.7. Okay, now you will ask, why EMF when starting is a 3? When I just on the circuit, why they will drop? Okay, so when you think about that, we see about 3 volt. When 3 volt open circuit means we only got one resistor. What resistor? Internal resistor. That one is in the battery. Agree? So when I just close the circuit, I extra another resistor. What is that? The outside one, no? The external. Okay, just now we put the bulb, is it? So that means I need to overcome the bulb again. So now we got 2 resistors already. No? One is an internal, another one should be the external. So that means now the circuit, they show the voltmeter reading will be dropped. This one drop reading 2.7, we call it as a potential difference. Okay, potential difference. Now they never touching about internal already. They just say, oh, now it's a normal V equal IR. Okay, understand or not? For this one situation, we can find EMF. We also can find the potential difference. But you must know EMF only can find when open circuit. Okay, potential difference only can be found when you close circuit. Okay, when you close circuit already, actually you totally cannot see EMF already. You just can see it's a potential difference. Okay, from here we just drop down the reading. Open circuit, the bulb sure off. Okay, closed circuit, sure the bulb will be on. Okay, now you see the voltmeter reading. Open is 3 volt. When it just closed, there's a 2.7. Okay, now we're going to see the next part. Okay, we do some discussion. Okay, this one is closed circuit 3 volt, open circuit 2.7. So the first one, they ask you, what is the change in the energy when the bulb is light up? Okay, what energy they convert? Sure, first one you can say about the chemical. Okay, number two, sure is a electrical. Okay, finally electrical, they will go through to the light. Okay, light must together with the heat. Okay, this one is a totally complete energy changes. Okay, so from here we can see the answer. Electrical energy, they're straightforward to the light and also the heat. Okay, so remember they never mention about chemical. We're just talking the main one. From the electrical, straightforward light and also the heat. Okay, number two, based on the result activity, which one circuit measure the potential difference across the bulb? Okay, which one? 3 volt or 2.7 measure potential difference of the bulb? Okay, anybody can answer me? Okay, 3 volt or you say 2.7 to measure the potential difference of the bulb. Okay, anybody here just type there? Okay, I will see your answer here. Which one measure potential difference of the bulb? Okay, you just answer me 3 volt or 2.7 volt. Okay, yeah. They told me there's a 2.7. Yeah, that's a correct. So 2.7, they show about the potential difference of the bulb. Okay, so from here, there's a closed circuit. Okay, when there's a closed circuit, we can see potential difference. When you just open circuit, we totally cannot see. We just can see EMF. Okay, now we go to the B. What is the quantity of the electrical energy released by the bulb in for the 1 coulomb of the charge flow through it? Actually, this one sentence what they're talking about. Okay, they're talking about EMF, is it? They say that what is the quantity electrical energy released from the bulb 1 coulomb of the charge flow through it. Flow through it means the whole circuit. So from here, actually, they ask about EMF. So the EMF here is how many? So the EMF here is I forget to see one more thing. Is it what is the quantity of the electrical energy released? Bulb. I forget to see the bulb. So when I just mentioned the bulb, so you're talking about 2.7. If I never mention the bulb, they say whole circuit, then you're talking about EMF. So from here, they say bulb. Get released by the bulb for 1 coulomb of the charge. So we just take 2.7, make it become joule. So we just explain 2.7 joule of the electrical energy emitted to the bulb for 1 coulomb of the charge. Okay, only the bulb. So you can say, if not bulb, we're just talking about point to point. That one is a potential difference. Okay, so from here, number 3, what is the EMF of the dry cell? So I think everybody know the EMF is 3 volt. Okay, so from this one diagram, hopefully you understand what is the EMF, what is a potential difference. Okay, now we do some comparison in table form. Okay, first one, the EMF. Okay, the circuit you can see. First one that just open, then we can read the reading. That one is an EMF. Okay, you want to read the reading for the potential difference, you must close the circuit. So that means the bulb can be light up, then you can read the potential difference. Okay, so from here they say no current flow in the circuit when you want to read the EMF. So this one you want to read about potential difference, there must got current to flow through the circuit. Okay, for the EMF, voltmeter reading in open circuit, that's an EMF. Voltmeter reading is in closed circuit, that one call it voltage across the bulb, that one is a potential difference. Okay, third one, what's the difference? Sure is a definition. Okay, let's see the definition for the EMF. Total work done by a source. Okay, they got mentioned about the source in driving 1 coulomb of the charge around complete circuit. Okay, they got source, they got complete circuit. Okay, let's see the potential difference. Potential difference is work done. Okay, work done to move 1 coulomb of the charge between 2 points. That's all. Only between 2 points. Okay, so this one is a what differences for the EMF and also potential difference. Okay, then we need to go, after introduce the EMF, then we need to go should be the internal resistance. Okay, let's see the next part. Okay, this one is one of the activity. They want to find out the effect of the internal resistance on the voltage drop. Okay, just now we see already the diagram. 3-volt drop until 2.7, is it? So from here now we need to explain why drop. Okay, so from here the apparatus almost the same. Okay, just they're using different battery. We're using brand A and also brand B. Okay, after that switch, they're also using the bulb, then connecting wire, ammeter, and also voltmeter. Okay, first one, they're going to check the dry cell you are using. Okay, make sure both dry cells should be the new. Okay, because we want to fair. We don't want the dry cell already used for the others electrical appliances. We don't want. We're starting by both also is the same one and also the new one. Okay, the voltage still the full and also brand different. Okay, now we set up the apparatus like this. Brand A. We're using the brand A first. Okay, so from here you need to record. Record the voltmeter reading for the EMF in the table before you start the experiment. That means you just open circuit. You go to record what's the reading for the brand A. Okay, close the circuit and record the voltmeter reading for the potential difference. Okay, now you need to calculate the differences in the voltmeter reading before and after the switch close and also open. So you repeat using the brand B. Okay, so from here we find it, the voltmeter reading when before they close, that means you just open. Brand A is 1.5, brand B also 1.5. That means there's a new one. New one, sure, okay lah. Both EMF is the same. Okay, we never say energizer and also every different one. When starting they provide 1.5 volt, another one they provide 1.4. No, when you buy exactly there's a 1.5 volt. Okay, after you use a sure different, depends on it. Okay, now you're going to see now the situation is the bulb is the same. Okay, we on the time also is the same. You see what's the difference? Voltmeter reading after close, after you close the switch. Okay, you find it, one become 1.4, another one become 1.3. This one 1.4 actually is what potential difference. This one also 1.3 is a potential difference. Okay, now I need to find voltage drop. That means the voltage you minus the one we call voltage drop. So from here we're using the formula. Voltage drop is a I small r. Okay, current should be constant because internal resistance and also the external resistance, there's a in series. Okay, when there is a in series, the current is constant. So both currents should be the same lah. So from here, I multiply the small r, we call it as a voltage drop. Okay, if the I and also the capital R, the one is a potential difference. This one is what we learned before. So today I want to introduce a new potential, a new voltage. There's a voltage drop. IR equal EMF minus potential difference. So that one we call voltage drop. So from here we get it. For the brand A, drop 0.1 volt. For the brand B, they drop 0.2 volt. Okay, so this one is what we can see from the table. Brand A and brand B, what's the difference? So we do some discussion for this one result. Okay, why should the new dry cell be used in this one activity? We need to using the new dry cell means we want to make sure the original starting, the battery sure is a full one. Okay, so that means they do not any loss of the energy. So from here, the answer, make sure that the EMF for the both battery are equal. So we're using the new one. No? If we're using the old one, that means we cannot say both is the same. maybe one already used so many, another one left. So from here, we need to starting by both also is a new one. Okay, so from here they say which one brand of the dry cell that experiences the greater the voltage drop. So from here we see it's a brand B, is it? Okay, so the brand B has a higher voltage drop. So from here, why is there a difference in the voltage drop between the two dry cells? Why one is 0.1, another one 0.2? Why become like this? So we need to explain. Okay, the voltage drop is a different because the internal resistance are different. So this one is a one thing is related with the internal resistance. Although the EMF is the same, but inside the battery, the internal is different. To overcome the internal resistance, is it for this topic? Before that, we ignore only. We never count about internal resistance. But this one topic, we need to count about internal resistance. So from here, you can see the differences of the voltage drop. Important is a small r. Not because of the current. Current already is a constant. Important is the small r. So that means now the small r in the both brand different. Okay, you need to overcome the resistance. If you're using more current to overcome the resistance, so that means the voltage drop should increase. It will drop more. So from here they say voltage drop is a different because the internal resistance are different in the both brand. Okay, every brand of the dry cell has the different type of the electrolyte. Electrolyte means the internal resistance. So the cell that will with high internal resistance, they will have higher voltage drop. Okay, so you now understand what's the internal resistance. Okay, internal resistance also same like the resistance. They also need the current to overcome. But internal resistance and external one, sure internal is very small lah. So that's why just now before that we learn the topic we can ignore. But this one topic they need to detail a bit, so we need to count internal resistance. Okay, so now you know voltage drop important because of the internal resistance, not because of the external, it's the internal. Okay, so depend the battery. If the battery internal resistance is less, that means you just drop a bit lah. If the internal resistance is high, that means you will drop more voltage. Okay, understand? Okay, so we go through to the next part. Okay, now we need to find the equation. Okay, we learn so much. EMF, we learn about potential difference, we learn about current, we learn about internal resistance. So we need to make some relationship. Then we create the equation. Okay, you can see the diagram here. This one is a 1.5 volt is a EMF. Okay, inside the battery, we got internal resistance. Okay, this one is outside the battery. Outside the battery, we got external resistance. This one is for the bulb. Then after that, we got voltmeter. Voltmeter, they show you 0.3 ampere. Then the this one V. V, they measure the load potential difference. That's a 1.2 volt. Okay, so from here, I go to show some reading first. Okay, position of the switch when open and also the close. Okay, when starting, okay, this one voltmeter sure they want to measure the bulb. Important the voltmeter, you want to measure the battery. Actually, they put at the top of the battery. So from here, you just ignore this one diagram, how they draw it. Okay, so we just see the table first. Okay, the state of the bulb when it open, sure off. Okay, another one close. Okay, you close, the bulb sure will on. Okay, how about the ammeter? Ammeter, the first one, 0. Okay, 0 ampere. Okay, 0 ampere, no current pass through. Okay, when I just close, okay, got current already. Now the current is how many? 0.3 ampere. Okay, now you can see this one diagram. They sure want to put another voltmeter here because we do know the battery is how many volt. If no, you buy the battery, then you understood lah. There's a 1.5 volt. Okay, although you never measure by using the voltmeter, but when you new buy one, the battery sure is a 1.5 volt. So from here they say when open circuit, when open circuit sure is a EMF. So there's a 1.5. When I just close circuit, okay, now this one voltmeter, they want to read for the load only. So this one voltmeter, they show 1.2 volt. So this one 1.2 volt, actually the name we call it as a potential difference. 1.5 volt, we call it as a EMF. Okay, now I write the whole equation. Okay, 1.5 volt EMF equal 1.2 volt potential difference for the bulb plus what? The voltage drop. Okay, drop how many? 0.3 volt. So this one we call it as a drop in potential difference. The formula is a I small r. Okay, so now I need to join the whole thing, become one of the formula. So the formula will become, okay, voltage drop will equal to the EMF minus potential difference. So potential difference you also can write as a negative IR plus EMF. Finally, EMF is equal to the potential difference plus voltage drop. This one is important for the EMF equation. Okay, so before that we learn about V equal IR, where we use for this part only, capital V. So this one should be V equal IR. But now we got EMF, you need to using the full formula. EMF equal capital V plus I small r. Okay, so from here we go through to the next part. Internal resistance. What is the definition? Okay, internal resistance of the drive cell, there is a resistance that caused by the electrolyte in the drive cell. That means they only related for the drive cell. Okay, SI unit is still the same. Ohm. Also is an ohm. So you can see the battery here. So inside we got one of the switch. We got battery. Then this one is an EMF. Okay, batteries, the symbol, this one is an EMF. This one should be the internal resistance. So this one potential difference. This one is a voltmeter. They want to measure EMF is how many. When I just close circuit, that means now the V that will show the potential difference of the load resistance. This one also same. The diagram should be the same. Okay, so from here, internal resistance causes. Okay, what that causes? First one, loss of energy. Because you need to overcome the internal resistance, is it? So loss of energy as a heat in the dry cell as the work done. Okay, work has been done to move 1 coulomb of the charge against the resistance within the dry cell. So they just want to overcome the resistance in the dry cell. So finally, the heat will be lost. So this one is an internal resistance causes. Okay, number 2, the potential difference across the dry cell terminal to be less than the EMF. Okay, when the current flow in the circuit. So that means when the current just flow in the circuit, the potential difference they will drop. Okay, because of the internal resistance. Okay, they need to overcome the internal resistance. Finally, the potential difference reading sure less than the EMF. Okay, so this one is one of the thing causes by the internal resistance. One is a heat energy, another one is a reading of the potential difference. They will drop. Okay, so finally, just want to introduce voltage drop. The formula is a I small r symbol equal EMF minus potential difference. Okay, now I want to conclude this equation. So this equation we can write as a IR capital R plus small r. Okay, because this one we can convert become IR. V equal IR. This one is for the external resistance. This one is the internal. So I can write I capital R plus I small r. So depend the situation. If the question never give you potential difference, they give you external resistance. So you need to using this formula. Okay, or we can combine. Take out the I, the current should be the same. Then bracket capital R plus small r. Okay, so this one is another formula for the EMF. Okay, so from here the explanation, E is stand for the EMF, V is a potential difference across the variable resistor. Okay, then we got current, we got internal resistance of the dry cell, we got external resistance. Okay, understand? So from here, the student, if you don't have any problem, so we need to start for problem solving. Problem solving means you are ready for calculator. Okay, prepare your calculator. After that, I will ask the question, then you just typing in the chat room. Okay, so today we just got only 18 students is watching now. Okay, so we go through first question. Okay, figure they show about two circuit with the dry cell, the arranged in series and also in parallel. Okay, series and also parallel. You see, I focus to the dry cell, not focus for the external resistance. You focus to the dry cell. Okay, first one, they given that the EMF of the dry cell for every dry cell, each dry cell 1.5 volt. Okay, and the internal resistance is 0.5 ohm. Okay, so from here we write the info lah. Okay, every EMF 1.5. Okay, understood now. We can see the first one. First one is a series of the battery. So it's series, the volt we need to plus together, is it? So I can say for the series, the EMF will become 3. Okay, for the parallel, the EMF is how many? Still 1.5. Okay, so now the second one should be the internal resistance. Okay, internal resistance also inside the battery, is it? So internal resistance for the series is how many? We just plus 0.5 plus 0.5. So that should be the 1 ohm. Okay, in parallel, how? In parallel, remember, we need to put 1 over R equal 1 over R1 plus 1 over R2. That one, the situation you need to do. But now, both also 0.5, easier. Okay, we just take 0.5 over how many battery? 2. 0.5 over 2. Then the answer is 0.25 ohm. Okay, for the EMF. Okay, external, both also is the same, 10 ohm. Okay, now we're going to see the question. Okay, compare the current flow into circuit. Okay, the series and also parallel. Is it the current is the same? Okay, we need to do calculations. Okay, we need to show about calculation. Okay, let's see the first one, how we go to start first. Okay, we need to file EMF. Okay, we need to file the EMF first. Okay, first one, this one is the info before that. So we're going to see the series, the part for the series first. Okay, series. First one, internal resistance. This one is a series. So 0.5 plus 0.5, that's a 1 ohm. Okay, no problem. Then we go to number 2. Continue. Okay, we need to apply the formula because you want to find the current, is it? Okay, for this one situation, we cannot using potential difference because here no potential difference. We do know the current, so that means we cannot do the potential difference. We just can using the, take out the I, the capital R plus small r. Okay, so from here, EMF, we know already. The EMF is how many? 1.5 plus 1.5 becomes 3. Okay, so from here, we just write the current, you want to find the current, EMF over capital R plus small r. Okay, so I continue. Remember, EMF, I straightforward put 3 already because this one is a series. Then external resistance, how many? 10. Okay, internal is how many? Just now we find it. 1. So we just over 11. So the first one I show you, the second one you need to show me. Okay, morning. So from here, 0.27 ampere. Okay, 3 over 11. 0.27 ampere. Okay, so this one is a series. Okay, now I want you to show me is parallel. Okay, question number, same question, but now that I want to find is parallel. Okay, I'll give you some info first. Okay, we need to find out the internal resistance. Internal resistance is a 1 over 0.5 plus 1 over 0.5, then 0.25 ohm. Okay, using the same formula, I want you to give me the answer for current. Okay, I want the current answer. Okay, so from here, the student in the live, you can live chat here can answer me. Okay, Esther is here, is it? Esther, you can answer me this question. Okay, I just want to find current only. Okay, the method should be the same as before that. Okay, just the internal resistance is a different. Okay, we're going to see the answer for the current pass through the circuit. Because from here, we just can using the eyes to see it. Okay, suppose we know lah, because internal resistance, when you find it in parallel, sure becomes smaller, is it? Internal resistance becomes smaller, sure the current become bigger lah. So this one is understood for logic calculation when you see the diagram. But then you still need to show it why you say like this. Okay, anybody can answer? What's the answer for the current when they pass in parallel? Okay, we see the student can answer me or not. Okay, still nobody. Excuse me. Okay, anyone you just get the answer, you can type inside the chat. Okay, Yiru give me 0.1463 ampere. Okay, so we go to check. Okay, we pin the answer from Yiru first. Okay, so we just put all the thing in. Okay, Ling Han also give me the same answer. Okay, so we go to check. Okay, 1.5 here. The EMF is a 1.5 not 3 because this one in parallel. So over 10 plus 0.25. So the answer, yeah, correct. Exactly 0.1463 ampere. Okay, so we continue to the next part. Okay, we can do comparison already, like, is it? Just now we find the series and also parallel. Okay, series we get is 0.27. Okay, then the parallel by 1463 current. So from here, we know the current passed through the first one series sure is a more. Okay, why? Because they want to overcome the resistance. Okay, so from here, we can answer the which one arrangement dry cell give the greater current explain. So the greater current must be the series. Okay, why they put give you greater current? Because you combine, there already is a 3 volt. Okay, this one when you parallel, actually they give you is how many? Only 1.5 volt. But later you find it lost. Which one you lost more? And later we can find it. Which one arrangement they will lost more energy. Okay, for this one situation we find it. Sure will give more EMF is the first one. Okay, because you join 3 volt of the EMF. Okay, after that current go through also will be greater. Okay, because the resistance becomes smaller, resistance become higher. But when join do the calculation, then we find it the series they produce the current bigger. It is because of the higher effective EMF. Okay, important, you got higher EMF, they produce more current. Okay, so from here, if we never do any calculation, maybe we guess the wrong answer. Okay, so from here, when I just show the calculation, the first one 0.27, another one 0.1463. Okay, so we get it. The answer should be the first one, series. They will give more of the current. Okay, now number two. Number two, if the circuit in the 3.32B, this one, parallel one, is replaced with the 3 dry cell in parallel, what happened? They call you to calculate the current. So from here, I add another series. Okay, another battery. Okay, in parallel. So important what you think about that. Sure, the internal resistance drop because in parallel already, is it? So now what happened for the current? Okay, so from this one situation, we cannot say, oh, internal resistance increase, then the current drop. So from this one, we cannot using the formula V equal IR already, because we need to using the EMF. EMF equal capital 1 of the I bracket capital R plus small r. We got 1 of the small r. So that means we need to relate about that. When your small r becomes smaller, so what happened for the current? So this one is one of the thing we need to think about that. So we show by calculations. Okay, now we show the internal resistance first. Okay, this one is a before that, the info. Okay, now the internal resistance, you need to add one more. 1 over 0.5. So what I get it, now the internal resistance is 0.167. Okay, becomes smaller again. So now apply the same formula. Okay, find for me what is the current. Okay, I want the current. Okay, the student, you can try. Okay, you think about that. The EMF still 1.5 because you add as a parallel. So 1.5 fixed. After that, the current we don't know. R, capital R also is a fixed. Then the R becomes smaller. The R becomes smaller. So from here, what happened for the I? Okay. Just see what happened for the I. Okay, just now is your internal resistance changes, and also your EMF also changes. Now the situation is EMF constant, but the internal resistance changes. You see what happened for the current? So we're going to check the student whose one can be answered this question. Okay, we're going to find out. Okay, students still do calculation. Okay, we just wait a while for the student to answer it. Okay, we still don't have any answer, just waiting. Okay, Yiru, give me the answer already. 0.1475. Okay. So from here, I need to pin. Wait. Okay, yeah. So the answer, we're going to check, is it correct or not? Okay. The formula should be the same. Okay, just the R internal resistance, you change a bit. So from here, I put all the thing in. So I get it 0.1475. Okay, so just now is 0.1463, is it? So now it's up a bit, 0.1475. Okay, so that means now is EMF constant. R becomes smaller. When the R becomes smaller, you just divide, then understood the current will be increasing a bit increasing a bit, because the R is more changes. Okay, so from here you can find it. Now the current pass through increasing. Okay, so from here we cannot say, oh, we know the answer should be increased or decreased. We must show proof by using the calculation to show the answer. Okay, so from here, this is one of the example, chain about arrangement of the dry cell. Okay, now the next one, we jot down the reading. When I2 means the circuit only two battery in parallel. I is 3 parallel battery. Okay, we got it, 0.1475. Okay, now we need to compare. Okay, Sharon also correct. Okay, compare the current in the arrangement of the two dry cell. Two dry cell in parallel and 3 dry cell in parallel. So we know I3 is bigger a bit. Okay, I3 is bigger a bit. So we just answer the current in for the 3 dry cell arranged in parallel is higher. Okay, the higher a bit. Now we need to state the relationship between the number of the dry cell in parallel and the current in the circuit. So what relation you can say? So from here we can say when the dry cell in parallel circuit increasing. Okay, you arrange increasing for the parallel circuit. I find it the current will be increased. Agree or not? Is it? Because we find it I2 is more than I3, is it? So I can say like that. Okay, so they want you to explain why you say the relationship like this. Now we're going to see the answer. Increasing the number of dry cells that are arranged in parallel, that will increase the current in the circuit. Why? Because the effective internal resistance decreases. Okay, this one we're talking internal resistance, not talking about EMF, because EMF already is a constant. Now the problem is the effective resistance affect the current. Okay, so just now the series and parallel, that one is want to do the comparison with the EMF. But when parallel, actually we need to do the comparison with the internal resistance. Okay, so we go through to the next part. Okay, example 2. You can refer here. Okay, the diagram show a cell with the EMF 2. Okay, EMF, you see the diagram, they got 2 volts. And internal resistance is 1 ohm. It's connected to the resistor. This one resistor, we call it is the external resistor 4 ohm. So what is the reading of the voltmeter? Okay, when it is connected across the 4 ohm. Okay, actually they want to find what? They want to find potential difference. Because they say when there is a connected across the 4 ohm resistor. Okay, so from here we write the info first. Okay, we got EMF, we got internal resistance, we got external, then we want to find potential difference. So now you go to think, what formula we got potential difference? Actually, it's a V equal IR, is it? But we do know what is the current. Okay, we don't know what is the current. So we got to think another formula they can find potential difference, and also they got EMF. So from here we just find it. This one is the formula. Okay, capital E equal I bracket R plus R. The problem is to know the V. Okay, we also do know the internal resistance. We got. So we can use another one. Okay, capital E, V, we can straightforward to get it. Voltmeter when it is passed through it. Okay, for this one situation, actually what they want, all the things here, is it? Okay, this one's a current. Then to find the current. Okay, so sorry, so this one question a little bit problem. They want to find the reading of the voltmeter. So reading of the voltmeter, just a simple, we just V equal IR. They can find the answer. So from here, we need to get the answer is I. Okay, we need to take the answer for the I. Because from here, you want to get IR is okay, but no I. But from here, we get the answer from the I first. So we take 2 is a EMF. Capital R is a 4. Then plus internal, there's a 1. Okay, so from here, the I, we don't know. Okay, when I get the I, that means the rest we can settle it. So from here, we get the I first. Okay, I get it, the I is a 0.4 ampere. Okay, because there's a 2 over 5, 0.4 ampere. Okay, so from here, I left the student to do it. How to find voltmeter reading. Okay, how to find the voltmeter reading. Okay, so the student, please start now. I want V equal how many? The first part I help you already. First part I help you to find the current already. So now the second part you need to do to find the potential difference across the 4 ohm resistor. Okay, we just see the answer from the student. Just a simple question only, this one. Okay, anybody here can answer? Okay, we just apply the old formula what we learned before, because this one is a capital V. Okay, anybody? Important you get current. So if you get the current, that means you can solve already. Okay, anybody can answer. Ling Han can answer or not? Or Yiru? Okay, Ho Zhihui answer already. There's a 1.6 volt. Okay, we see how to show 1.6 volt. Okay, Tan Wei also, Alicia also, 1.6 volt. So we go to show. Okay, just now the formula we can write like this, is it? Capital V, is it? So straightforward, you can just put in, okay, V equal EMF minus IR. Okay, so the student can using the simple one. Simple one, just V equal IR, also same. You can get the same answer. So from here, if I using this formula, I just apply lah. Okay, V equal 2 minus 0.4 multiply 1. So final answer 1.6 volt. Okay, you can using the simple one, it's okay. V equal IR. Okay, Sharon also correct. Ling Han correct. So you just using V equal IR, you can straightforward to get the answer. Remember the R is what? Capital R. Okay, capital R. So we can get 1.6 volt. Okay, so we go to the next question. Okay, example 3. They got bulb M. Okay, the bulb M connected to the battery by means of the switch. Okay, a voltmeter is also connected across the battery. When the switch is open, the voltmeter reading 6 volt. Understood lah? When the switch is open, the voltmeter reading is a 6 volt. So 6 volt is what? EMF lah. Okay, when the switch is closed, the voltmeter read is 4.8. What's the 4.8? 4.8 is a potential difference. Okay, so from this one question, they never tell you exactly directly, you know. You need to understand the question, what they write. Open and close, what's the meaning? So from here, we can write that in for open is 6 volt. That one is an EMF. Close, there's a potential difference, 4.8 volt. So the first question they ask you, what is the EMF of the battery? So understood lah, 6 volt. Okay, number 2, B. If the resistance of the bulb M is 8 ohm, now they tell you the external is a 8 ohm. What is the current passed through the M when the switch is closed? So that means they want to find current. Okay, agree, yeah? But from here, what we do know, internal resistance, we don't know. Okay, internal resistance we don't know, but external we know. So external, you know, that means you can using the formula for the external only. Don't using the EMF, the long one, because we don't know internal. You don't know internal, that means you cannot solve anything. So that means we just using the simple one, the external one. So V equal IR. So V equal IR, this one is all capital letter. That means there's not related for the battery, only the external. So from here, anybody can tell me the current passed through the bulb is how many? Okay, we just read the answer from the student. V equal IR, 5 for me, what is the I? Okay, just a simple question. Okay, we wait the student to answer this question. I think there's no problem for you all. Okay, V equal IR. So you know what is the V. Which one should be the V? Then R, you want to take which one should be the R? Okay, we're going to wait the answer from the student here. Okay, got anybody to answer it? What is the current? Okay, student can count it. Press your calculator, simple only to get the answer. For this one, example 3B. Okay, anyone? Okay, I just waiting. So I don't know my line is low or I cannot see here. Okay, also again, the 猴子会 give me already. 猴子会 give me 0.6 ampere. Okay, now we go to check. Okay, Euro also same. Okay, just 4.8. Okay, 4.8 equal I, then bracket you put 8 lah, because this one they want to find the bulk one. So finally 0.6 ampere. Okay, correct. Your answer is correct. So the student make sure you need to know what situation we just using V equal IR and what situation we must using the EMF equation. Okay, so from here we're going through example 3 again. They got C. Okay, C. Okay, just now the info we write here, EMF is the 6. After that, potential difference. Then just now we get the answer from the Euro and also the Zihui. They already give me 0.6 ampere. So now the final answer they want to find internal resistance. Okay, when they want to find the internal resistance, that means you need to including the whole formula lah for the EMF. So we just write excuse me, EMF equal potential difference plus I small r. Okay, I think this one also is no problem for yours. Okay, find for me what is the internal resistance. Okay, internal resistance from the student answer. Okay, also just a simple thing, is it? Okay, we just all the thing you just put in the formula, then we can find out already what is the internal resistance. So important is you write all the info. Okay, you write out all the info, then you are more clear when you do the calculations. Okay, so from here we can see the answer from the student. 0.6 is the EMF, then the potential difference is 4.8, then you got it already 0.6. Okay, now the problem you need to find is the internal resistance. Okay, we're going to find out from the student what's the answer for the internal resistance. Okay, anyone? Okay, we wait a while for the student to send the answer here. Okay, go or not? Okay, Alicia, they give me the answer 2. 2 what? Okay, you find resistance, so we must put the unit. Okay, I think you cannot write the ohm. Okay, yeah, Ling Han write the word already. Okay, 2 OHM ohm. Okay, because the symbol you don't have, is it? Okay, so we just show. Okay, so there's a 6. Okay, Sharon also answered 2. Yuru also is a 2. So from here, 6 equal 4.8. Okay, after that plus, then you bracket 0.6. Okay, it's a current. Then after that, you got R. So you need to find is a small r. Okay, so from here, the small r is 2 ohm. Okay, that's correct. Okay, Sika Jing also correct. Okay, then we go to the number 4. Okay, number 4. So when the switch S is open, the voltmeter reading 1.5. Okay, understood lah. Okay, when the switch is closed, the reading is 1.35. Okay, student understand about this, and the ammeter reading 0.3. Okay, so info, we just write the info. Okay, so from here, first one they ask EMF. Okay, I also want to ask you lah, you also know what's the answer for EMF. Okay, EMF is 1.5 volt, everybody know. Okay, number 2, internal resistance. Okay, actually you got so many patterns to find internal resistance. You can straightforward to minus EMF minus potential difference, there's a voltage drop, is it? So the voltage drop, you can divide the current, then you can find internal resistance. Okay, so from here, the student, I want the answer from B, internal resistance. Okay, I want the answer from yours. Internal resistance, the answer is how many? Okay, just finish, then you can type. Yeah, Jia so far 0.5 ohm. Okay, 0.5 ohm from the Jia. Okay, so Zihui also same. Okay, so we go to put the number. Okay, formula. Then 1.5, 1.35, you go to minus, divide by 0.3. Yes, 0.5 ohm. Okay, that's the answer. Then we continue the C. Okay, C they want to find is the external resistance, the big one. Okay, so from here you also can find it from the capital V. Capital V, you can straightforward to find the capital R. Remember the formula? V equal IR. Okay, the current should be the same one because the current is go through the whole circuit. Okay, so from here, I want to answer C. Okay, anybody can type here. What's the answer for the resistor? Okay, this one is an external resistor. What is the answer? Okay. Okay, you can see the student who want to answer this question. The R is how many? Okay, the student every time they will answer one. Friday, the Charan is not here. Nixon also not here. Lynette also never answer. So mean this one don't know where to go already. Okay. Then check. How many students can write the answer for the R? Okay. So we still got some of the question. So our lesson is almost end from 11:30 lah. Hopefully can lah. Okay, if you can answer all the questions. Okay, Zihui, 4.5 ohm. Okay. Yiru also 4.5 ohm. Okay, we're going to check. Is it correct or not? Sikajing also 4.5 ohm. Okay, now we're going to check. Okay, 1.35 over 0.3. Okay, 0.3. Then after that, we get 4.5 ohm. Okay, correct. The answer is 4.5 ohm. Okay, so now you make sure you know how to using this formula already. Okay, so we continue to the, okay, this one is finished already. So this one is a one on the homework you need to do. I already share in your group. Okay, for the student, if you don't have the cannot receive any the info about this exercise, so you can go through this one link. Okay, some student they're just using handphone, is it? You can scan about this one, the barcode. After that, you can get this one exercise. Okay, for my student, that means you can through the Telegram, you can download. Okay, you can download the exercise and solve it. And this one exercise we discuss for the tomorrow lesson. Okay, tomorrow lesson. Okay, so for the student, then on your subscribe, please subscribe and also click the bell. Okay, thank you for your watching and also for the class. So today we end earlier a bit, 11:20. So just thank you for watching. So that means you need to start your module to do the exercise for 3.3. Okay, so the student, thank you. Thank you, Yiru. Thank you, the student, for answering me just now the question. Thank you, Sharon, Sigajing. After that, we got Ling Han, we got Ho Jia Yao. Okay, then we got Ho Zihui to answer my question. Lim Zixuan, thank you. Okay, so thank you for the students. So see you tomorrow again. Okay, bye.